Hello engineers, welcome to Mechanical Training World channel. Today we will discuss about UG-40 from the ASME BPVC Section VIII Division 1 code guys. That is limits of reinforcement. Before going to the topic, if you are new to my channel, please subscribe and click on the bell icon. You will get notified if I upload any new videos guys. So let's begin the topic. Understanding the limits of reinforcement is crucial for static engineers guys because it helps to determine the maximum dimensions where we can place the reinforcement. To indicate that maximum dimensions for the reinforcement, the code given that they are rectangular box guys, which indicate the limit of reinforcement. So reinforcement provided outside the limits of reinforcement will not be considered as a reinforcement guys. So whatever the reinforcement you are provided, whatever the reinforcement pads you are provided within this rectangular box only. If you provided a outside this rectangular box, that is not considered as a reinforcement because these are the boundaries within which additional material must be located to compensate the material removed for the opening guys. We need to select maximum dimension in both scenarios guys. One is normal to the vessel and other is parallel to the vessel wall guys. So first one we need to consider limit of reinforcement which is parallel to the vessel wall. So the limit of reinforcement on each side of the axis of the opening must extend to greater of these two values guys. That is maximum of D or Rn plus Tn plus T guys. So where Rn is the inside nozzle radius, Tn is the nozzle wall thickness and T is the vessel wall thickness guys. So your value must be maximum of these two values. In most of the scenarios, if D value is the maximum, that is the finished diameter of the opening guys. So if D is the maximum, then total distance parallel to the visual wall is 2D guys. I hope you are getting the point. So this is all about parallel to the visual wall. So now let's see limit of reinforcement normal to the visual wall. This reinforcement must lie within the smaller of the two values, that is minimum of 2.5 into T. This T is nothing but the visual wall thickness, or 2.5 into Tn plus Te. Te is the effective thickness of the reinforcement pad guys. This is your reinforcement pad. So Te is our effective thickness for the reinforcement pad and Tn is the nozzle wall thickness. Here you can see. So you need to consider the minimum value from these two values. So this is the limit of reinforcement for the normal side to the visual wall guys. So I hope you are getting the point. So this is all about UG-40 guys, that is limit of reinforcement. In next lecture we will see that nozzle with reinforcement calculations problem.